IUPAC nomenclature of organic compounds, right? Organic compounds, I said that the structures, their names, both the things must be understood very well. If the name is given, you should be able to write down the structure, and if the structure is given, you should be able to write down the name. So what IUPAC is? IUPAC, it's a union, international union of pure and applied chemistry. It's a group of people, or you can say it's a community worldwide that looks after the nomenclature. We know that there are like hundreds and millions of hydrocarbons, there are millions of organic molecules, so they can't be named randomly. If you start naming them after the name of a scientist, it will be very difficult to memorize, it will be difficult to understand. Just like a periodic table, the arrangement of the elements which help us to understand, okay, this element falls below the metallic part, so the for sure the element must be a metal. Same way, IUPAC gives some common rules, right? It gives some common rules so that the compounds can be understood very well all around the world. So IUPAC, it's a set of rules to name the organic compound. Many organic compounds have their common names. Like if I discovered something, right, I'll name it after me. But after the intervention or after the formation of the IUPAC, even that compound which was given a common name, it is given a new name as per the IUPAC rules. It's just like roll numbers given to you in your classroom, right? So you are given some identity codes. Same way, all the compounds are named as per IUPAC rules. So let us see nomenclature of organic compounds. So naming of organic compounds, right? Any name you take, it has got all these parts. We will understand what each and every part means, right? This is one example. Let's say this is one organic compound, right? This is one whole organic compound. You can see some numbering is done, right? Some circles are put up, right? And then finally we get a name as 5-methyl hex 3 into all. How did this name came in? 5-methyl hex 3 into all. So this name has come from the IUPAC rules, and as per that IUPAC rules, right, the name will have one or more following parts. One or more following parts. The name will have prefix. You can see here, this is some prefix. Prefix may be in the number form. Prefix may also be in a word form. So prefixes are of two types. Either they are some words, right, or you can say some alphabetical letters, and prefixes may also be in the form of numbers. We call it as numerical prefix, or here they have used the word infix. Then you have a root word, the most important part, a base name, which will help us to identify the most part of the organic compound. So base name, which help us to identify the like you can say a maximum part, or you may be very close to the name if you can identify the base name. So base name has got two parts, word root and primary suffix. From the primary suffix, after the primary suffix, there may be a secondary suffix too. But root word and primary suffix are the main part, and addition to this, all such parts may be present. So you can see this name, it has got prefix, it has got word root, it has got primary suffix, it has got secondary suffix. So what all such words will mean, right? We'll see them one after the word, one after the other. The first one which we will understand, it's a root word. So what does the root or a root word means, or you can also say a word root. So word root represents number of carbon atoms. Word root represents number of carbon atoms. let's say if I write down a compound, like let's say when I write such compound, right, the most important part in this compound is the number of carbon atoms, the chain. So how do you identify the chain? So identifying the chain, or you may say identifying the number of carbon atoms, the word root is the solution. To identify the number of carbon atoms, the word root is the solution. So if there is only one carbon atom in the compound will have a word root meth, right? We had gone through, or we commonly know methane. So how the methane came in? You know that CH4 it's called as a methane. So how this word came? This word came from the combination of meth and ANE. Meth represents one carbon atom and ANE it's a functional group which represents that there is a single bond. Once again, write word root. It represents number of carbon atoms. For example, we know methane. From where did we get this word methane? So methane is made up of two parts, meth plus ANE. Meth means one carbon atom and ANE means the functional group which says that there is only a single bond. Another example, if I say like say pent. So from pent we will have pentane. So pentane has again got two parts. Pent means there are 5 carbon atoms, 1, 2, 3, 4, 5 carbon atoms, and all of them have a single bond. So ANE. And then the next step will be by default to place the hydrogen atoms. This is just a notation. If I write down its condensed formula, the condensed formula would be like this, right? 1, 2, 3, 4 and 5. This is the condensed formula. Structural formula can be made from this. You can add hydrogens to all the free dash that you can see. So this will be a structural formula. This will be a condensed formula for the pentane. And then you also have a molecular formula C5H12. How this molecular formula came in, that we will see when we discuss the ANE family, right? So word root, it means number of carbon atoms. Word root we also call this, sometimes they call it as a prefix, but I suggest you to remember it as a word root. So word root means number of carbon atoms. If there is one carbon atom, we call it as meth. 2 eth. For 3 carbon atoms, we call it as prop. For 4 but. For 5 pent. For 6 hex. 7 carbon atoms, we use hept. For 8 carbon atoms, oct. For 9 carbon atoms, non. For 10 carbon atoms, dec. So till 10, it's common thing to remember, or you should compulsorily remember. But if there are 11 carbon atoms and so on, it depends upon your interest if you want to remember the word root. For 11, the word root is undec, dodec, 13 triadec, for 14 it's tetradec, for 15 it's pentadec, for 20 it is ecos, for 30 it is triacont, and so on. But remembering the word root till 10 is suggested. So now we know what the word root is. Word root tells us about the number of carbon atoms, right? It tells us about the number of carbon atoms. Then next we have primary suffix. You can see here the primary suffix. This is the primary suffix. So what does the primary suffix tells us about? Primary suffix tells us about the nature of bond, nature of covalent bond. That means either single bond is present, or double bond is present, or triple bond is present. Primary suffix gives us the idea of nature of bond, either single bond or double bond or triple bond. If the primary suffix is ane, it means there is only single bond. We saw the examples of methane, ethane, propane. If the primary suffix has the word ene, that means the double bond is present, and if the primary suffix has the word yne, that means the triple bond is present. Now you can see here in this compound there is double bond present. If at least one double bond is there, the compound becomes ene. if at least one triple bond is there, the compound becomes Y-N-A. Right? So single bonds are ignored. The double bond will be given the preference. And due to this double bond, you can see here the primary suffix En is used. ENE or En. It's again based on the rule how En came. It's again the rule. As we go through, you'll understand why the last E is dropped. So ENE, En, it is a primary suffix. Then secondary suffix tells us about the functional group. Which functional group or to what family does this compound belong? Right? Apart from the nature of the bond, nature of bond given by primary suffix, secondary suffix identifies the functional group. So here you have a secondary suffix. See, OL. What it does, OL represents alcohol family. See here, the functional group you should identify it. For alcohol, right, ROH is the general notation of the functional group. In addition to OH, R may be anything. So you can see this is completely a R part. An alkyl or alkene, right, or alkenyl radical it may be. So ROH, functional group present over here is OH, right, and that is why we have OL as a secondary suffix. And what does these numbers denote? These numbers represent the position of those functional groups or position of those suffixes, right? How do we identify the position? We'll see in the further rules. So in a IUPAC name, in this syntax, now the word root should be clear to you. It represents number of carbon atoms. Primary suffix, you should be very clear that it represents a nature of bond, right? Secondary suffix represents the family or the functional group. Alcohol family, this is the example. Prefixes and infixes we will see. So primary suffix, right, it represents the degree of saturation or unsaturation. Degree of saturation or unsaturation in the sense that if it is saturated, only single bond will be present, and if it is unsaturated, double bond or triple bond may be present. So primary suffix, you don't have to remember those words, just understand that primary suffix represents the nature of bond. If it is a single bond, further you can identify it as a saturated. If it is a double bond or triple bond, you can identify or you can have a extra information that it is a unsaturated compound. Type of bond and the primary suffix, right, I already explained. For single bond the suffix is ANE, for double bond the suffix is ENE, and for the triple bond the suffix is YNE. Secondary suffix represents the functional group, right? So for alkenes, right, there is no secondary suffix. Secondary suffixes are given over here. For alcohol the secondary suffix is OL. For alkenes the secondary suffix is ENE, YNE for alkyne. For aldehyde the secondary suffix is OL, and the CHO is a identifying group, or from the structure or in the structure, if such group is present, that means the suffix, the secondary suffix should be AL. The secondary suffix should be AL. So these are some of the structures and their corresponding suffixes that you may find in name. Again, the table must be memorized, if not all, at least alkene, alkyl, halides, alcohol, aldehydes, ketones, ether, acid, esters. You should remember that if such group is present, right, or in the name OAT is present, that means it belongs to a ester family. If such group is present, right, or if OAT is present, it belongs to the carboxylate ion. COH is present, or if oic acid you see in the name, that means it is a carboxylic family. So secondary suffix, it represents the functional groups. These are some of the secondary suffixes and corresponding functional groups and their structures. Prefixes. Some radicals are always represented by prefix. Some radicals are always represented by prefix. What are those radicals? F, the halogen fluorine. It's always represented by the prefix. It does not have any suffix. Some of the functional groups also have a prefix as well as a suffix, right? When do we use prefix, when do we use suffix? Again, it's a part of the rule, but suffix means dominating functional group and prefix means a, you can say, a add-on functional group, right? Suffix means dominating functional group and prefix means it's a add-on functional group, or you can say an add-on feature. So like if I explain you in terms of carboxylic acids, if there is a compound, like if that compound has carboxy, if that compound name has carboxy, that means the functional group COOH, that means the functional group COOH is used over there as a additional attachment. It's used as a additional add-on. Once again, if in a name, if you see carboxy, right, that means the functional group COOH is used as an additional attachment. It's not a primary functional group. But if in a name, if you see oic acid, in a name, if you see oic acid, that means this functional group COOH is a primary functional group. It does not act as a attachment. It's a primary functional group. This functional group will give you the feature to that complete compound.